friends, check out this exercise. We have to find the shaded area of the figure. Let's recognize that here we have a quarter of a circle, a square, and here we have a semicircle with an area of 10. Very well, what we are going to do first is find the radius of this semicircle and multiply it by 2 to find its diameter. Very well, the midpoint of this semicircle is roughly around here, and this would be the radius and this as well. Very well. Now we know that the area of a semicircle, which we are going to symbolize like this. It is p times the radius squared over 2. Excellent. Now we know the area of the semicircle is 10. And this is going to be equal to this here. We are going to move this 2 to multiply here. It remains like this. And on the right side, we will only have p times the radius squared. Now we are going to move the p to divide. And we get 2 times 10, which gives us 20 over pi. And on the right side, we will have r squared. Applying the square root on both sides of the equation, and we are not going to apply the properties of absolute values because we only want the positive part. So, simplifying here using index and exponent, we have found that the radius of this semicircle is equal to the square root of 20 over pi. Yeah! Fascinating, we already have the radius here, and we can find out the diameter because the radius is twice the diameter. So then the diameter is equal to twice the radius, and the radius is this here. So we have twice the square root of 20 over pi. Excellent, right? But notice that the diameter is the entire side of the square. Very well, that means the whole side measures 2 times the square root of 20 over pi. Yali. Now what we are going to do is draw a line from this point to this point, and notice that this point is the midpoint of the side of the square, because we have some markings here indicating that this side is divided into 2 equal parts here. So what we are going to do is draw a line from here to here like this. Very well. Now this line here is the radius of the quarter circle that is in blue. If the radius of the large quarter circle, we are going to call it capital R. Very well. Now you know the length of this side of this right triangle, because here you will see 90 degrees. We have a right triangle, and this side will measure the square root of 20 over pi. Because earlier we had divided this side of the square, and half of the square side is the radius of this semicircle. So we have here half of the square side, which is this part here. This measures then square root of 20 over pi. Excellent. Now we will be able to apply the very powerful Pythagorean theorem in this right triangle here. And we will say that the hypotenuse is squared. We will put here that the hypotenuse squared is equal to each leg squared, and they added up. Very good. The hypotenuse, which is capital R, let's denote it as r squared. This will be equal to a squared, which is this here. So let's put it in parentheses too. Square root of 20. All of this over ps. Very well. Over p squared, right? Plus the other side, which is this one here. So plus open parentheses, the square root of 20 over p. And all this squared. We then have that r squared is equal to 2 squared, which is 4 square root of 20. So here the index is simplified with the exponent, and we have 20 over pi. Very well. And over here we will have more. We simplify the index with the exponent, and we have 20 over p. Very well. 20 over p. Notice here, if we multiply 4 by 20, we get 80. Let's write 80 over pi plus 20 over pi. From here we can deduce that r squared is equal. Since it is a homogeneous sum, the denominator is preserved and the numerators are added. 80 plus 20, which is 100. We have, ladies and gentlemen, the radius squared of our quarter circle, and with this we can say that the shaded area, ladies and gentlemen, is equal to the area of the quarter circle, which we will symbolize like this, minus the area of this semicircle, which measures 10. Now what is the area of a quarter circle? Well, it's pi. By radius squared over 4 this r, I will write with a capital R, because you know it's this r here, right? The radius of this quarter circle that we have here, which we already know how much it is. It's this here. So let's replace it. We have here 100 and below. We will have this p here. We simplify p here and pi there. A fourth here and a fourth of 100 is 25. And gentlemen and ladies, the area shaded by Newton's beard is 25 minus 10, which gives us 15 square units. Impressive. Let me know in the comments if you liked the video, and don't forget to subscribe, give it a like, and share it so you don't miss the upcoming challenges. See you another time. Bye-bye.